you get some limitations. So here you see I'm using, if you look at bottom left hand side, so I'm using the free version. So there are some n number of interactions that you can do with GitHub Copilot. After that, it will not let you do that, and the limit resets, I think, after a month. So there is a limit to which you can actually use this capability in a, I think, in a month. So you see, you have got the code here side by side, which you can copy and run. So this is the thing, in Collab Notebook, we were able to run the code in the browser itself. Here it's not the case actually. You will need to copy this code, paste it on some software and run it and then verify it for you. So it has actually given you two versions of the code, simple QA agent. So you can try and see the results for yourself. So this is another second tool which you can take help of to work on your programming skill, building machine learning based, not even machine learning where you want to build some front end application, Java based application. So you can take help of it. Yeah, now let's go to the next set of tools. Yeah. So now next set of tools that I'll take you through are related to research domain. Let's say you want to research about a specific topic. You want to work on your own research. You want to understand what's happening in the industry right now. So there are these two tools which you can use, very powerful one. So one is Elicit, second is Science Navigator. So I'll take you through these tools now. So let's go to Elicit. Here you can see Elicit this. In the name itself, you can see AI for scientific research. And here in the description, you can see it uses AI to search, summarize, extract data, and chat over 125 million research papers which are there, used by over 2 million research in academics and industry. So let's go through it. Let me type the name. So it gives you options, but you don't have to pick. You can just say continue without pro. Skip. Yeah. So you get free version also. You don't have to pay anything. And that lets you actually do a lot of things. You can find papers related to a research topic. You can do chat with papers. Let's say you have a paper with you. You can upload it and you can ask questions from it. You can also generate research reports here. So let's start with a question. Let's say you want to find a paper on AI tools for education. So let's see how AI in education. You want to research on this topic. So I write this topic and instantly you can see it has come up with these three options to refine the query or prompt that I have written. So it gives that you can make it more specific. So specificity is like, what is the impact of AI-powered personalized learning platforms on student academic performance in secondary school? And then it gives another option of intervention focus. How do AI-driven adaptive assessment tools affect learning outcomes, student engagement in mathematics? Or you want to do a comparison. So to what extent does AI assisted instruction differs from traditional teaching methods in improving learning outcome? So you can see I just written this one phrase. I can continue with this phrase also, but it gives me three options. More precise questions work better. You see, it has given this, which is actually the right thing. So let's say I click here, comparative approach. So it will modify my question and prompt. And after that, you see it gives you option like what kind of sources you want to refer to. So you want to refer to research paper or clinical trial. So it basis on this, it ensures that whatever study or research you are doing, it is backed by some research paper, not some blog which is written on internet. So it looks at only the authenticated source to find the papers related to topic that you're interested in. So now let's click here. And you see, it has started giving you responses basis on the topic that you had given in the query. So here you see the first most relevant paper is the collision between traditional methods and new learning, the difference between AI-assisted teaching and classroom teaching, and its effect on students' English writing. And along with the paper, it provides you a quick summary also, which is AI generated. So you can quickly go through this instead of reading the entire paper. It has given you this crisp summary. So AI-assisted instructions show greater improvement in EFL writing skills compared to traditional teaching. Then you go to the second step. So here also it has given a summary. So for every paper, so it has given you a rank order list of 10 papers found for this topic, along with a summary of what is there in the paper. Then there is a third frame also here, which you can see. It gives you a quick explanation also, and it gives you a step-by-step paper here, and it gives you a very easy to understand explanation here that you can go through. So you can go to page by page, first page, second page, and you can see all the explanation written here, which is coming from the actual content of the paper. So this is how you can research on any topic that you are interested in. Apart from that, there is another option, paper chat. So if I click here, what you can do, you can upload any paper and ask questions related to it. Then there is this third option here, inside popular workflows, is to generate the research report. So here what you can do, ask a research question to generate a structured research report. It has given you some options. So you can pick from any of these or maybe write your own research topic. Let me pick the second one, magnesium effects on sleep. So let me click here and let's hit enter. So you see, it gives you this paper being created. And if you see at the right hand side here, it gives you a step-by-step process of how it has created this report for you. So if you see here first, it gathered 499 sources. These are research papers related to the topic that you have written, which is this. Then it screened from this, it filtered 14 sources. From there, it extracted 98 data points, and from that, it generated this final report. So this is the step-by-step workflow it has created to generate the report which you are seeing here. So you can see it has information on different trials which were done. So you see quality measure. So basically it is the effect of magnesium in sleep and stress. So it has created this entire research report based on whatever is available in Elicit's research paper repository. It has extracted information from that. So this is how you can use Elicit to do or work on any research topic that you are interested in. The another tool is your science navigator. Let me quickly take you through that also. So you can see this is the one. It is now renamed to Borium. So name itself AI for Science with Global Scientists. So AI for Science with Global Scientists and AI powered all-in-one research hub is what this offers you. So when you click here, so you see similar type of interfaces there. Here also you can ask any specific question. At the left hand, you can see it has options of doing academic search, doing chat, then multiple options are there. You can create your own knowledge database. You can search from a knowledge database. Then here it gives you option to write a question. So here multiple options are here which you can choose, or let's say you have something of your own. So let's pick this one, how to model non-normality and extremes in asset prices. And it also has, you see the sources, like which types of sources you want. I think I'll need to log in. I'm not logged in. Yeah. So both the tools, as you can see, they provide you similar sort of interface, and both are used for doing the academic research. So this was your how to use AI tool for academic research. Now I'll go to some tools which you can use for working on your soft skills. So soft skills basically include your presentation skills, writing skills. So let me take you through some specialized AI tools. And I'll also take you through, let's say you don't want to use it because these voice-based tools a lot of time are paid. So Udly is very popular one. It is used for AI role plays. But this is not entirely free. 5 interactions with Udly are free. But let's say you are done with those 5 interactions. After that, you will need to pay. So that's the issue with it. So here you see practice. If I click here, it will actually let you, yeah, I am out of it, out of all the credits. But basically what you can do, you can practice for any of your upcoming presentation. You will need to turn on the video. So what it will do, it will analyze your facial expression, your voice modulation, the way you are speaking, the usage of word that you have in your presentation. And basis on that, it will give you feedback on what to improve on. So this is something like a coach you can use for working on your communication and presentation skill. But only 5 are available for free. Let's say you don't want to use it, you can try actually ChatGPT also. So ChatGPT, as you can see, it has a voice mode. So what you can do, you can ask it to act as a voice coach for my upcoming presentation, or can be interview also. So let's say you want to prepare for an interview and you want ChatGPT to rate you on certain aspects. So you can give actually ChatGPT more information here that I'm interviewed for this position. Can you help me in preparing for it? You can actually ask it to generate some sample questions also and quiz you on those. So all of that you can do here also. So let's say I hit enter. So you see, nice, let's get you sounding confident and clear. How your voice should, so you see here it says it will cover how your voice should sound, pace, tone, energy, simple warm-ups to do right before you speak, how to answer questions in an interview without rambling, a mini practice script you can use today. So in this way, you can take help also of GPT. You can turn on this voice mode from here, use voice mode, and you can actually talk and ask it to analyze. So you see, voice is also now integrated in ChatGPT. So it can do the conversations with you in real time. It can help you with all these communication aspects, which is very crucial for while delivering a presentation or giving an interview. Yeah. So these are the two things you can use for working on your soft skills. So now let's go back to the slides. Yeah. So this is all part of your learning phase, working on your skill, upskilling yourself in all the aspects like programming, tech, research, or let's say a soft skill area like communication or writing. So these are just slides on some hands-on, which we just saw actually. We have covered all of it. Now let's move to the second topic. Second topic is associated with content design and delivery phase. So how to design content for your upcoming course that you are going to be taking for a specific topic, and how you can create interactive media or slides using the content that we have generated. So for that, what I'll do, I'll start with first a goal or an objective that we want to achieve. So let's say this is the goal that you have as a faculty, that you have to deliver a 1 week module on a specific topic, and these are certain requirements you have in mind. So the course that you are going to be delivering in this 1 week should have 3 measurable outcomes that should follow Bloom's apply analyze. So remember I had mentioned Bloom's 2 sigma problem. So Benjamin Bloom had done a lot of study in this field on how to improve the learning of students, people, by applying a certain set of principles. So this is part, apply and analyze is actually part of those principles, that whatever you teach should have a measurable outcome associated with it. So this is, we'll see how we can use this to generate a course plan when I'll take you through the respective AI tools. So the idea is to include 3 measurable outcomes following Bloom's apply analyze. It will have a 90-minute live session plan. So they will, the AI tool should give you segments also, like what to be covered in during what duration, 2 asynchronous activity, then some OER reading videos. These should be verified open links. Then you have a requirement of getting 1 graded assessment also with rubric to judge the result. So this will be your 4 criteria across 4 levels. So this is the requirement you have. And in case of online learning, it is important to add accessibility considerations also. So this is also we will put in the prompt that we will write. Now the tools which I will take you through will fall into these 2 categories. So first, I will use Perplexity. So Perplexity is very popular. I think some of you might have already used it. So I will use Perplexity for sourcing open educational resources, which is your OER. And I'll tell you why we are using Perplexity for that. And after that, we'll use ChatGPT also for creating the template, which will include all these objective or the requirements we have. So again, we'll go through a 2-step process in designing the content for the upcoming lecture, let's say, or the course that you are going to be delivering using these tools. This is just a quick reference material I have put in here. So phases of online learning. So Bloom's taxonomy. If you remember, this is what I have written in the objective, Bloom's apply, analyze. So basically Bloom has this 6 tags that whatever you teach should fall in any of these 6 categories, like remember, understand, should be able to apply, analyze, evaluate, or create. So this is the Bloom's taxonomy's example I had given in that. How to pick, tag your item outcomes. So everything is what I put in here as a reference. Now, before I begin, quick question I have for all of you. So Perplexity, which we use a lot, some of you might have used. This is a AI search engine or a LLM or a large language model. So this quick question I have for you. So drop in chat, what do you think? It's an AI search engine or a large language model or a GenAI model? So you can drop your responses in chat. Or it is both also, you can say that also. That is both AI search engine and LLM. So drop your responses in chat. What do you feel? What is Perplexity? AI search engine or large language model? Okay, I got one response, both. LLM. Okay, so now we will do a hands-on activity, and there I'll explain you what actually Perplexity is. So let's wait till we go to Perplexity's user interface. So let's see the prompt. They look a lot, but these are actually static prompts we will be using. So as I said, these are the 2 AI tools I will be using. First, I'll use Perplexity. That we will use for source gathering, identifying the right resources using which you can prepare your content. And then there are these 3 prompts which actually we'll use in ChatGPT. So Perplexity is actually a preferred source because you whatever research on topic you are doing for your course delivery, it should come from authenticated resources. So this is the advantage of using Perplexity. It will give you links, citations from where it has picked up that information. So you will be able to go to this resource, those resources, and identify whether they look legitimate or not. It should not pick something from some random website or a blog. So that all you can enforce with Perplexity. So now I start with writing these prompt in the Perplexity. So let's go to Perplexity. And this is Perplexity's user interface. Now I had asked all of you a question, what is Perplexity AI? So if I just do a quick Google search on Perplexity, let's see what we have here. So as you can see, it says Perplexity is a free AI-powered search engine that provides accurate, trusted, and real-time answer to any question. So actually, it's a AI-powered search engine. It's not a LLM in itself. It's not a Gen AI model. It uses other companies' LLM to provide you accurate and trusted results. And this I'll show you now. Let's go to Perplexity website. So here in the Perplexity's user interface, you see these icons, web search, choose a model. So if I click here, choose a model, you can see there are a wide variety of models you can pick. It has Sonar, GPT. So GPT 5.1 is your OpenAI's model. Claude is your Anthropic model. Gemini comes from Google. Grok is by X. This is some new model which has come. Claude is again by Anthropic. So basically, Perplexity lets you use all of these models. You can pick any one coming from different vendors. So it's actually Perplexity in itself is not a LLM. What it does a very sophisticated search, whatever query that you write here. And behind the scene, it uses those LLM to structure the responses. So basically, it's just using the LLM to put a right structure in which you can see in its user interface. So Perplexity is, you can think of as a wrapper built on top of your LLM model. In itself, it doesn't have any of its own LLM. It might happen in future. Perplexity comes up with its own Gen AI or LLM model, but currently that is not the case. So if I go to Chat GPT, so you see it has option for only GPT models because these are the models provided by OpenAI. So OpenAI is the uh, company which creates these GPT models. So you won't see here Gemini as an option or Grok or Claude as an option because these are the competitors. But if you go to Perplexity, it lets you pick and choose any of the model because this is not the core functionality of it. So you can think Perplexity is your competitor for Google search. So it falls under the category of search engines. So now what I'll do next, I'll paste this prompt here and you will be able to see it clearly when I paste it in Perplexity. So now let's read what this prompt says. So it says find 8 to 10 authoritative recent sources on topic. Now topic is a placeholder that you will need to replace. So the topic that I'm interested in is data pre-processing for data analysis. This topic can be different. You will have to write what topic you are interested in, but that is the placeholder that you need to rewrite. And these are some examples I have given related to data pre-processing. After that, I put some constraints on the result that the result should preferably come from NPTEL, scikit-learn documents. So scikit-learn is very popular Python library which works on data processing. Then it can come from university pages also, because those are usually also authenticated sources, textbooks, OER readings, openly available readings, which are authentic sources. After that, I enforce a structure on the output, that output should come as a table with these headers. And here you see I put a constraint that exclude personal blogs, unverifiable sites, mark which are OER. So this is the prompt I have. So let me hit enter. So it's working on doing the research. And you see this option or the note that 3 steps completed. If you click here, you see from whatever query I had given, it did a search on these phrases like data processing for data analysis on these, data processing scikit-learn documentation. So the way Google does the search, it did the search, it extracted the component, and then it passed to your large language model to come up with this formatted response that you are seeing. So you see, it has given you a tabular structure. You have the title, link. So you see it's the scikit-learn document link. And here it talks about pre-processing of the data, imputation of missing value. It has picked that from scikit-learn. Data pre-processing, it has taken it from IGNU. So it has given you this PDF link also. Then NPTEL, IIT, KGP, YouTube link it has provided you. So is it in this way it has provided you all the links based on the constraint which we had given that. So prefer these resources for extracting the information. Now you see, we have this information. Now we want to put it in a structure in a PDF of 2 to 3 page, which we can use for delivering the content. So now what I'll do, I'll paste the second prompt again inside Perplexity. So here you see this is the prompt. So from the sources above, produce a 1-page teacher brief. It is one, you can make it 2, 3, 4 basis on your requirement. Brief on topic. Topic is again the placeholder. So let's replace this. The topic, this was the topic which we were interested. Then you specify what all you want, what sections you want, like some key ideas, common pitfalls, do-don't checklist, 3 short example. Then you have this constraint that every claim must have an inline citation. So whatever claim it is being made, it should have a citation so that you can go and verify that claim. So this is one. And if a point lacks a source, omit it. So it means do not put it in the 2-page teacher brief that you are preparing. So this is the second prompt we are writing. So let's hit enter. So it has started generating the content, and it has put relevant citations also with every statement. So data pre-processing, transform raw data. So this is the key idea it has put here. Then what are some of the common pitfalls? So data leakage, some do-don't checklist. So split, train, and test before any pre-processing. And it can see it has given you right a set of links also, which user can go and refer. So you can this way verify that it is coming from the right source. Some examples we had asked, so it has given you 3 examples. So in this way, whatever ask you had, it has prepared approximately 2 page brief for you. Now what you can do as a next step, you can rewrite, copy or export. So in export also, you see it provides you 3 options: PDF, Markdown, DocX. So if let's say you're fine with this as it is, you can export it as PDF. You want to make some edits of your own, export it as docx, make the edits and then use it. Let me export it as PDF. So see, I've got the PDF here, and this is how it looks like. So key ideas, common pitfalls, do, don't checklist, short examples, along with all the relevant links are here. So in this way, you have got your like teaching material ready. Now we have one more requirement to create a session plan with requirements that we saw in the slide. So we had a lot more requirements. So for completing those, we can use ChatGPT because we are not generating any reading material. We will be just taking its help in restructuring and creating the course plan. So ChatGPT is fine for that. So let's create a new chat. And there are 3 prompts which I will use. So I'll take you through this step by step. What are these prompts and what we need to replace to make it personalized to our requirement. Let me zoom in. So you can see this is the first prompt. We are not asking it anything to do. We are just giving a persona to GPT model here. So if you know about prompt engineering, so here we are actually using the prompt engineering and how to write prompt to give your AI model a persona so that it can act accordingly. So here you see we are giving this conversation we are having with GPT a role that in this instant it is a higher educational instructor designer for India. Familiar with, then whatever you see in the brackets, these are placeholders. You can replace it with whatever you want. I've just provided here some sample values. After that, you provided information that who's going to be the audience. So you can replace it accordingly. If your students are high school, UG, PG, working professionals, so all of that edits you can make here. Bandwidth means what sort of internet they will be having. Let's say you are delivering online classes. So what sort of bandwidth they have. LMS, Moodle, Google Classroom. Constraints. So what constraints you should have while working on any task you give. Output style, table first, then concise bullet, no marketing tone. So this is just what a persona we are giving to this interaction we are having with ChatGPT. So let's me hit enter. So this is the first one where we are not making any changes. So it is just given a basic, we can like it is just a reference that it has given, nothing to do with what we actually want. What we actually want starts with the second prompt that we will write. Yeah. So now let's put this prompt. So what we are saying here, write 4 measurable learning outcomes for topics. So this topic is what will be we had given in Perplexity. So the same topic, this one. So saying write 4 measurable learning outcomes for data pre-processing for data analysis at Bloom's apply analyze. Map each learning outcome to a course outcome as CO1, CO4. Suggest the evidence to measure it, how to measure the learnings that you are giving to students, and return it in this table format. Since it has created certain learning outcomes that how to apply appropriate missing value imputation methods, analyze variable distributions, transforming data, construct a reproducible pre-processing pipeline. What outcome description looks like. Learner scan clean incomplete data set and choose context fit techniques. How you can like evidence you can look at that the person has understood this concept. So in this way, it has created this learning outcome table. Now we'll write the final prompt, which is to do the session planning. And here, here I'll provide two information. So using learning outcomes generated above. So here we can see. So this is the learning outcome table it has created. So generated above, and slide outline or paste is this is actually the perplexity output we got, which is your PDF. So let's copy this entire content, or you can upload it also here, that using learning outcomes generated above and the attached PDF with the course content. You can do that also. And content given below. So here I am just pasting whatever content we generated. Then you are asking it to create a 90-minute plan, split into 10 to 15-minute segments, plus 2 asynchronous activities with time estimates. Output table should be like this: segment, minute, purpose, what to show, do, tools. Then list 2 asynchronous tasks. So let's hit enter. So see, it has generated, it has started generating 90-minute live session plan following activate, teach, practice, and reflect principle. So your first segment is raw activate, raw data inspection, 10 minutes. Purpose is surface prior knowledge, identify issue. What to show? Display small tabular raw data set with missing values, mixed types, prompt where problem exists. So similarly, you can see it has created multiple segments, minutes, purpose, and what to show or do. Two async activities. So async task 1, download provided mini data set, perform some activity on it. Then another async activity, give 3 processing logs and submit a short text answer or marked worksheet. So this is how you can come up with the entire course plan. And this what you see table is actually you can copy it, and let's say you have you can, if let's say you're using Google Sheets, you can just paste it here. So you can see it's copy pastable. You don't have to make any formatting or anything. So you have segment, minute, so you can use it for your reference. Purpose, what to show, do. So all of that you have available with you here. Now let's say you want to create presentation or slides for the PPT content you want to generate. So whatever you got in the PDF, let's say you want to now convert it into slides. So these days there are multiple tools available for slide generation. Google Gemini is also now can generate slides for you. You can just paste the content, it can do that for you. There is Gamma also. So gamma.app. So this is also you can use. Presentations.ai is also there, which you can use. So this is one of the slides I had prepared on the same topic. So let me show you how you can do the slide generation. Uh, this is this provides you a lot of free credits. So you can actually create 10 to 15 presentation. But let's say if you have Gemini available to you, you can take help of that also. So here with the Gamma, you go to create new with AI, click on generate. You can paste everything which was there in the PDF. Click on edit prompt. With the free version, there is one restriction. You will get only 10 like slides at once. So you can break down your content and generate 10 slides each. Or let's say if you want only 10 slides, so that will work for you. So let me click generate. So you see in real time, it has started generating the content for you, mastering data pre-processing, the foundation of reliable machine learning, core pre-processing steps. So all that information is available here. So this is how you can take help of AI tools for generating presentations for whatever course you are taking, whatever upcoming presentations you have. This is not the only tool. A lot of like AI tools are available now. Take help of Gemini also. Presentations.ai is also there. So you can use all of those tools, and all of them, these are editable. It's not like whatever information you get once, you cannot edit. So let's say you go through this presentation created by these AI tools and you are not happy with some of the content or some content looks incorrect. So you can go and make edits also. So you see, everything is editable here. And I would again emphasize, always do a proofreading. Sometime what content it is being generated can be misleading, incorrect. So always go through everything, all the content which you see in these AI generated text and output. Yeah, so this was how to design the content and create the presentations. So now let's move to demos we have already seen. That slide generation is also done. Now we'll go to the assessment phase, which is to assess the learnings of, let's say, yourself or your students. How to take help of these AI tools in creating, coming up with the MCQs and doing auto grading. So here, talking about the tools, you can use ChatGPT also for generating the quizzes. There are some specialized tool also like Quizzy, which you can try out. I'll first take you through ChatGPT, where you can write this prompt and get your quizzes in no time. So let's copy this prompt. So in the same chat, let's say from the above, for the above content, you can say for the above content, create 5 items. It says 2 MCQs with misconception-based distractors, 1 numeric, 1 scenario-based answer, 1 interpret the graph type question, and provide answer key and 4x4 rubric for short and scenario type questions. So with this prompt, let's hit enter. You see, it has started giving you the MCQs that you can use. And we had said specifically misconception based. So where students usually have misconception. So generate relevant examples for that. So you see the quiz one is there, quiz two is there on Canon Imputer, numeric example. So we had asked for 2 MCQs and then a numerical example. So here you see it says you split a data set into this. Then what is the scale value? So here actually a student needs to do the calculation and come up with a number. Then scenario based answer. So you give a scenario and ask student that what would be the right answer for this question. Then you have the interpret the graph item. So here you provide a let's say a graphic, let's say box plot, and ask it to analyze and come up with the answer. Then it provides you a rubric also 4x4, which will help you in grading students. So let's say someone has, so for MCQs it is easy, but for questions like interpret the graph where people have to write something, how to assess their responses. So here you have the criteria and what number you can provide them. Concept identification, let's say you want to understand if the person has understood the concept correctly or not. So here you can see like when to give 4 excellent, correctly identifies leakage affected steps. Identify leakage but not specific steps. So you can give that person 3. For 2, vague mention of wrong order. 1, nothing answered. So in this way, this is how you can come up with the scoring criteria for different concepts. So this is how you can generate quizzes using ChatGPT. If let's say you want to work on some specialized tools, so Quizy is also there, which is very popularly used. So it's called Bayground now. So you see it's used for all the classroom-based information creation. So you can log in here, paste the reading, or you can provide it a topic and it will generate the quizzes for you. So you see it has option of create. So when you click here, it provides you multiple options, creating flashcard, passages, video presentation. The first is assessment. So let's click here. And you see it has integrated AI here. So you can click on this, generate with AI. And here you can write in text or prompt, like for which topic you want to generate quizzes. You can specify websites or YouTube links also from which, let's say, you want to generate the quizzes. So it will do that for you. Or let's say if you have a document and from that you want to generate the quizzes. So you can do that also. You can specify number of quizzes, grade. So it has option from professional development, university, 12th, 11th grade. Subject, you can choose, it's optional. So by picking all these options, this is how you can use Quizy for generating the quizzes. If you want to create from scratch, so you can do that also and create on your own also. So this is how you can use these different tools for the assessment of faith. Yeah, so this is the demo we just saw. Now let's move to the last phase, which is your analytics phase. So where what you can do, you can use these AI tools to analyze discussion summaries, learning insights. So let's say you had given a quiz to students, and basis on that, you want to analyze what are some areas where students are struggling with. Or let's say you have LMS portals where students are discussing some topics. You want to analyze those discussion and come up with the summaries on where people are struggling, what misconceptions people have. So all of that you can do in the analytics phase. And this is a sample prompt I will use now. And what I've done, I've exported a sample chat conversation happening in a LMS, which I paste along with this announcement prompt that you see here. So in this announcement prompt, you see it says summarize these posts into theme, misconception, and a 15-minute practice task for clearing those misconceptions. Write a supportive 120-word announcement. So this is the prompt I'll use now. With this, I will need to provide some information also, which it will analyze. So what I've done, I've created this is a sample exported file for, let's say, if you use Google Classroom, it provides you an option to export all the chats which are happening. So let's say I copy this entire conversation. So here it has different values. So whatever you see as a text is what someone has written in the classroom. So let me paste all of this here. And at the end, I have this instruction that summarize these posts into themes, misconceptions, and a 15-minute practice task. Write a supportive 120-word announcement. So let's hit enter. So you see it has come up with a summary table of what are the themes of the discussions students are having. Split first, then reprocess, correct ideas, misconceptions, theme of handling missing values, impute on train to avoid leakage. So you see what is the correct idea and what misconceptions people are having. Label coded for linear models, one hot when no ordinal meaning. So in this way, it summarizes all the discussion which I had pasted here in the JSON. And basis on that, it has come up with a practice task, 15-minute. What it says that what you can do, you can provide as an instructor a mini CSV with missing values, city categorical column, and a very skewed numeric field. What learners will do, they will split it, impute the price, apply the one hot encoding, standardize numerical feed, and submit one screenshot of transformed shapes plus 4-line justification referencing leakage avoidance. So this is the kind of practice task you can create and give to students basis on the misconceptions they have on the whatever topic you have given to them. You can do this for yourself also. You learned some new topic. You did a self-assessment and then you identify what are your weak points and use that as a next step to work on. This ends with a supportive announcement like thank you for contributing. So this is like a motivational thing you can put in the any LMS system as an announcement. So let's get back to the slide. So this was the fourth and the last phase, analytics phase. Now let's talk about how to use AI responsibly, using AI the right way for learning and education. So accuracy is first. As I already said that no AI is 100% correct. Always verify AI generated content with Perplexity or Google Scholar, where you get information along with the citation from where it has picked up that, so that you can click on that website or that link and verify the information. Second is privacy protection. Never include your or students' PII data in AI prompts like Aadhaar number. WhatsApp screenshots also you should never put in these tools. Use anonymized content only. If there is PII information, redact it or remove it. Always do proper attribution, cite all resources which you have taken from different places, add credits where it is due, accessibility standard, make content reachable for all your audience, provide caption, alternate text, and have a good color contrast which can be understood by everyone. The fifth is your academic integrity. So AI is okay for ideas, outlines, and practice. It is not allowed for proctored tests. So clearly disclose which AI use are allowed and which are prohibited. The last is use of AI detector. So AI detectors are very popular these days, but they are also not reliable. You upload a content to 3, 4 different AI detector, you will get a different score for using each of those. So they are also not very reliable. Instead, what you can do, ask students to maintain the versions of the history and the prompts that they have created to come up with a response. Conduct short vivas from the versions to assess whether that student actually understood that concept or not. So these are some responsible ways of using AI in education and online learning. Yeah, so this is all I had. Thank you, everyone. If you have any question, you can ask now.
This is the right time to ask your questions because we have Shikha here with us for another couple of minutes. Mm. Shikha, I request you to be online for another couple of minutes so that people can put their queries. Because this session was originally scheduled uh, a little later, but we had to reschedule it because of and I'm waiting for the next resource person because I told you there is some emergency at their place. So
Yeah, sure.
I'll request. Yeah, there is a question from Dr. Gayatri.
By the ChatGPT case diagram text form, how can we convert into image? Yeah, so for image, you will need to use the specialized model. So the latest model which can support image generation. So not every generative AI model that you use can support the image generation. So if you have the text, you ask it with a specialized model, like I think GPT 5.1 has support for it. So only those models will be able to generate text. But if you're using GPT 4.0, that will not be able to do that. You can use Gemini's models. The majority of those support image generation.
Right. Thank you so much, Shikha. Thank you for your time and for sharing all this valuable information with us. I'm sure the faculty members will use it a lot to plan their lessons and will also disseminate this information to the students as well. Uh, I'll request the faculty members to switch on their cameras if possible. We also have our next resource person, Dr. Surya Prakash Kuteti is here. Thank you so much, sir, for joining. I know there was a family medical uh, emergency at your place, uh, but you still joined. So thank you so much. Hello,
No
ma'am.
problem.
Smita, ma'am. Hello.
Yeah, good evening, everyone.
Sir, we cannot see you.
Let me check. Okay.
Yes, yes, now we can see you.
Mm.
And now because we are on Teams, we have the faculty members also, we can see them. So it's a great thing. And thank you once again, Prakash Kuteti sir, for joining us. I know there is,
Thanks, madam. No
yes,
problem.
and over to you for your session on NLP and computer vision.
Yeah,
And again, I'll request faculty members to make use of this time and interact and engage with sir to gain the maximum knowledge from him. Thank you. And he
yeah,
also helps to understand the questions so that you're able to get good marks in the assessment. Thank you.
yeah, yeah. Good evening. Actually, today's session, I will be predominantly focusing on deep neural networks and convolutional networks and prompt engineering because uh, NLP, if we include it, becomes it will not be able to cover in this 1.5 hours. So, but I can give you outline of NLP that is extension of what we are doing, what we'll be doing in this, right? So, good evening, everyone. Hope I am audible, right? Let me share my screen.
Yes, yes, you're audible.
So, is it visible? My screen? Can you see my screen?
Yes.
Yes. Yeah, good. So, good evening, everyone, once again. Today we'll be discussing about deep learning, CNN, and computer vision and prompt engineering, right? So, I restrict myself to these areas because it encompasses through various fields and dimensions. And natural language processing is just, kind of extension of what you actually see in machine learning, right? So, let me start. So, first thing we need to understand in a deep neural networks is to understand the concept of a network, right? So, this artificial neural network is actually conceptualized from human brain, right? So, in human brain, you see various components, right? Like dendrite, and you have something like axon and cell body, right? And if you see these x1, x2, x3, these are the data points, right? How they enter into this brain is through dendrite, and then it is getting processed here, right? So this is typically how human brain works, right? These are signals that we are calling, right? So this is essentially stemmed out in early 80s, right? And we want to create a computational model from this. So how do I map this to a computational model? So if you look at these touch points as dendrites, they are essentially your uh, construction of this model, right? Now, similarly, when you have x0 or some weight, etc., this is called synapse. So then you typically kind of decide how much importance you want to give to this particular signal. That importance is given by the weights, and so-called cell body can be mathematically formulated into two component node here. One is right. Suppose you have like this. One is summation component, other one is non-linear component. Now, question here is why do we need this non-linear component, right? So, to understand this, suppose if you see, right, a node in the network. Suppose I have two inputs, x1 and x2, and let's say these inputs are given to a particular node, right? This has two parts. One is summation part, other one is non-linear part, right? This essentially means you attach importance to each of these features. Now we assume that both of them become 0. You don't want this entire value to become 0, so introduce something called bias, right? Now this component will become omega 0 plus omega 1 x1 plus omega 2 x2. In other words, we say this as omega bar transpose x, right? The vector notation. So now when you apply this function, right, this is a sigmoid function, for example, or z, which is nothing but this is your z. You generalize z as summation over omega I xi, I equal to 0 to number of dimensions that we have, with x0 is set to 1 here, right? Now in this case, we need to understand the concept of non-linearity, right? So when you take a simple sigmoid function, it look like sigma f z is equal to 1 by 1 plus e power minus z. So when you plot this function, right, as a function of z, at z is equal to 0, this becomes 1 by 2, this is 0.5. As z increases, this fellow will vanish, so it approaches to 1 as z increases. And on the negative side, then it will blow up 1 by infinity or something like that, 0, right? This is sigmoid function. There are a couple of other functions like tan hyperbolic function, right? So this look like e power z minus e power minus z by minus z. So essentially what it means, if you plot this, right, suppose as z increases, this quantity will become e power z by e power z, right? Because e power minus z tends to 0. That is 1 here. Similarly, as x tends to minus infinity, this will be minus 1 here. So typically it look like this, right? So this kind of nonlinear function will be helpful for uneven data distribution. Data distribution where it acts as a kind of scaling between -1 and +1. So there are other functions. So such functions are called activation functions, right? Why these activation functions are important? Let me take a simple example. Assume that I have only one-dimensional data, right? Something like this. Suppose this is my axis. This is my 0, 1, 2, 3, 4, 5. This is -1, -2, -3, -5. Assume that I have set of examples like in the classification setup, right? You have some positive examples or some examples of one class, right? And another set of examples which are here. You see green dots and white dots, right? On either side. Now it is very difficult to draw a classification line here, decision boundary. You can't draw a decision boundary. Suppose if you draw a decision boundary here and say that this side it is positive instances, this side is negative instances, then these examples are misclassified. Similarly, if you draw a decision boundary here saying that these are positive examples, these are negative, then essentially again these are misclassified. So what if we construct a nonlinear feature space where each data point that you have into square of it, right? Then it look like this. So your axis will be something like this. This is 0. Earlier it is 1, it becomes 1 square, 2 becomes 2 square, 3 becomes 3 square, 4 becomes 4 square, right? Similarly, this is minus 1 square, minus 2 square, minus 3 square, minus 4 square, which is equal to 4 square, right? So then it is a quadratic function. Now when you plot this line, it will look like this. So it is a kind of digital literacy course we are talking about. That's why I'm getting into the fundamentals, right? Earlier we had fluency. In fluency, we talked about little more advanced stuff, right? So now equivalent to that, when you represent this, these minus 101, still these are points here, something like this. Equivalent points will be here. Then other points will, let me use this color, minus 5 square, minus 4 square, minus 3 square, something like this. So when you transform the feature space x to phi of x, where phi of x is equal to x square, it is a kind of mapping that you do, then you got this kind of feature space, right? Now it is easy for us to draw a classifier, something like this. You can draw multiple classifiers, right? Like this, right? So that's where this is the fundamental principle of support vector machines in classifier, right? Where you essentially look at optimal decision boundary. That means optimality in terms of the dividing these data points. So this same concept you will be leveraging here, but it is not like a universal extension of what you see in support vector machines into these nodes, right? Because here we introduce the concept of dropouts, right? Which means it might so happen that sometime in this network, you switch off some of the weights to 0. I will explain those things little later, but this is the concept of why do we need this nonlinear function. The purpose of nonlinear function is to learn the features, right? Now let me go back here. So these are the key characteristics of deep neural networks. Okay. So what it means that we have input layer and we have you know output layer, so on and so forth, right? And you are basically looking at weighted computations, right? Now, when you say neural network, why we call it deep? Because deep refers to number of hidden layers. So, which will help us to extract hierarchical features. When I say hierarchical features, it is something like this. Suppose you have a human face, right? Right? So what happens is what you see on the periphery, right? That is a kind of, these are low order features. The boundaries are low order features. Now suppose if some spots are there here, right? These are, more complex features. Similarly, if you take a bird, right? This example, we keep on doing this. When you take this bird, if you want to observe this beak, right? This is more complex feature compared to the boundary line of this. So when you want to infer these kind of complex features, you need to go deep inside the network, right? As the depth of this network increases, that means these are called hidden layers, right? So we have input layer here. So these are the input layer, then these are hidden layers, and this output layer. So all the layers which are in between your input layer and output layer, these are called hidden layers. So as you move deep inside the network, you are aspiring to infer higher order features. That is the intent of this, right? So the basic idea of a deep neural network is you want to learn the representations from the data rather than something like, you want to infer on your own, right? So naturally, this is what you wanted to uh, construct features from low level features. So a feature is something what you interpret as a human being, might be a complex feature to 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 automate it, right? So what the network does is it will construct more complex nonlinear functions which will act as features for subsequent layers. For example, let us say you have two features and two nodes, right? So you have weight attached to here. Assume that this is 1, this becomes 1 1, this becomes W12. Similarly, this is 2, W21, this becomes W22. When you look at this, right, the features that you construct here are basically W11 into X1 plus W12 X2 plus this applying some nonlinear function, right? Now assume that these values are readily available as part of your data set. Suppose instead of X1 and X2, suppose you have F of Z1 and F of Z2, they are more close to predicting your Y. So essentially what you do, the more deeper you go inside, more complex functions you are constructing, which means that you are extracting more meaningful features from the base data that you have. But these higher order features are humanly difficult to interpret, but machine can understand these features, right? What in this process, what happens? It will be able to unearth certain features which is otherwise not possible even for a human being to infer, right? So this is the core principle of depth of a neural network. There are two things here when you design these networks, right? So the first thing is that number of layers that you are talking about in this direction, and also number of nodes in each layer. So as you increase this, how do we decide number of nodes, right? This is again called model complexity. So let us understand this concept of model complexity. Let me take a scenario. I have a two-dimensional feature space with features x1, x2, and my data set is like this. Y with some positive examples and negative examples like this. Assume that when I distribute them on two-dimensional feature space, let us suppose I have something like this. These are all negative examples, and I have something like these are all positive examples, right? Now you can construct a complex decision boundary, something like this. You can start here like this, right? So you could have done another decision boundary, something like this. So in this case, my model is just y is equal to mx plus c, kind of a straight line, right? I'm taking this liberty of using math because all of you are uh, professors and faculty, right? Now, on the other hand, if you look at this has nonlinear, nonlinear and complex, right? Model. So the advantage of having this kind of linear model is this is a simple model. The as you reduce the complexity of the model, it is very likely that it will perform well on the data which has not seen earlier. That means it will lead to a reduction of variance, right? Though this model has high variance. Okay. Now let us understand this, right? Assume that you have people, right? Lot of students preparing for IIT exam. Assume that the students spend 18 hours per day, and they have scored really well in all their grand tests. But when they go to actual exam, right? And assume that they have not actually qualified in the mains. Okay. What could be the reason for that to happen? So a student is prepared so well, he has put actually 18 hours per day kind of effort, but still he could not clear the exam, right? Whereas somebody who has put around 10 to 12 hours, he could do well in the main exam. What could be the potential reason for this? So the potential reason for this is that the first person might have done lot of examples, but what is missing is probably variety of the problems, right? So we need to cover enough variety in the training set, isn't it? So that's why if that model has so complex, it is kind of remembering it is kind of remembering your outcome pattern, right? Whereas if you look at the simple model, even though it misclassifies couple of examples, still it is able to generalize well, right? So model complexity is an important aspect, and it is also a measure of degree of variance that we are talking about. Okay. So what I am trying to say here is that when you talk about neural networks, obviously you will have lot of data points and you want the model, let's say classification or regression problem we are interested in, and you kind of predicting the outcome, right? How do you decide whether you want to stick to traditional machine learning models or you want to use deep neural networks? On what basis you decide? Any idea? Hello? Any idea how do we decide that? Tell me. So I hope I'm audible, right? Am I audible?
Yes, sir. Yes,
So
you're
my
audible.
question is, nobody is responding when I am asking something.
Yeah, please respond. Faculty members request you
Otherwise,
to respond.
even actually, Zoom meeting is much better actually, because
Next
at
time
least
we will
that's
do it on Zoom, sir.
because switching over to multiple screen will be easy there.
Okay. Next time we'll
Yeah, no
next time
problem.
we'll do it on
So
Zoom. This was an experiment. We'll do it on
no
Zoom.
problem. That's okay. So what I'm trying to say here is that what I'm trying to say here is that when you have a lot of features and lot of data available, then traditional models may not be efficient enough or smart enough to extract inherent patterns here. Now, whereas in the case of neural networks, you have a lot of degrees of freedom to choose from, like number of layers and number of nodes within the layer, etc. So that gives you flexibility to fine tune the fine tune the model, right, based on the inferences that you are getting. So that is the reason we need to know about deep neural networks, right? So these are the some of the key characteristics of deep neural networks. One is automatic feature extraction, because traditional machine learning relies on feature engineering, which is done a kind of human activity, right? On the other hand, deep neural networks, they learn features from the data through layers, through activation nodes, right? Now another thing is neural networks also help you to handle high dimensional data, right? That means images, text, sensor data, and all that. But when it comes to natural language processing, you map the sentence into sequence of tokens, right? Now, how do you extract in NLP these features? Let me explain you. So, in the context of NLP, right? Because NLP also we have. In natural language processing, you construct tokens from the sentence. Suppose I have sentence which is given by I like sweets, right? For example. Now you simply say that sentence dot split, right? This is my word tokens is equal to sentence dot split. Then you will have individual tokens I like this. Now after that, what you do? You kind of construct map into vectors, right? You map them to vectors. And before that, you do certain steps called stemming and lemmatization. Stemming means you cut the unwanted things. For example, sweets, you have sweet is the core word, right? And lemmatization, it will also look at context pertaining to the language, under consideration. So now you construct a vector from these tokens through some embedding scheme, then you give this to the neural network. Now, main difference between NLP type of problems and this is NLP requires context associated with predecessor. That means what next word, right? Is your next word. It depends upon your predecessor words. So that's where you improve these neural network models which can incorporate this context. These are something like LSTM models. That means long short term memory, right? Sorry. So, but whether you are doing NLP or image processing or pure uh, structured data model, right? Essentially, what you have is a neural network model at the abstract level, right? So that's how the networks help you to capture nonlinear relationships. I already explained that to you. That means you are having higher order feature constructions, which is much better than something like support vector machine or logistic regression, right? And because of the complexity associated with these models, if you have a large number of data set with significantly many features, then probably you can look at neural network as a good option, right? So let us take a simple perceptron model. So when you say perceptron model, it is a neural network without any hidden layer. There is no hidden layer, right? These are these are just inputs that are giving to a node, a single node. So you can divide this into two halves, sigma and nonlinearity. This nonlinearity is denoted by G here. Okay. So assume that this nonlinearity is sigmoid function, sigma of z e power minus z kind of a thing. Now assume that these are the weights. Now you have equation something like this: 1 by 1 plus 1 is the bias here, right? So 1 into minus 10 plus omega 2 20 x1 plus omega 3 20 x3. something like this. So this becomes 1 by 1 plus e to the power of minus. So G means sigma of Z, right? So which means G of Z is 1 by 1 plus e power minus Z. Now if you assume that the simple OR gate problem, so what is OR gate? When you add 0 plus 1, 1, 1 plus 0, 1, 1 plus 1 also, actually 2, 1, 0, actually you are ignoring carry here. That's how it is. When both are 0, it is g of minus 10. We know that in the sigmoid function, right? So any negative value of z is making it close to 0, right? G of minus 10 is somewhere here. So this is 0. In the case of 0, 1, minus 10 plus 1, 20 plus 10, this is g of plus 10, which can be 1. So that's how you are getting output as 0, 1, 1, 1. So given the input patterns, different combinations of x1, x2, you got following output pattern which is similar to OR gate. Now let us look at AND. So in case of AND, what happens here? Again, this is my omega transpose x bar, which is minus 3 into 1 plus 20 into x1 plus 20 into x2. Now again you put here x1, x2, h theta of x, again 0, 0. Suppose you put z here, z is minus 30. This is sigma of minus 30, which is 0. 1, 0. 1, 0 means it is minus 10. Sigma of minus 10 is 0. Same thing happens with 0, 1 also. Now when you make 1, 1, this becomes minus 30 plus 20 plus 20. This becomes plus 10. Sigma of 10 is plus 1. So that means the output is 1 only when both inputs are 1. Rest of the things it is 0. So it is behaving as if an AND gate, right? But if you plot these data points, right? So this is 0, 0. This is 1, 0. This is 0, 1. And you have 1, 1 here, right? So when you map these data points to a kind of positive class and negative class, you can, this can be equivalent to drawing some lines like this, right? Now let us take slightly different approach, that is XOR problem. In XOR problem, what happens is, you have examples like this. This is negative example. This is another negative example. It is very difficult to draw a line here in this case, right? Unlike previous stuff, you can't draw a linear decision boundary, right? So essentially what does it mean is, sorry, you have, this is minus, it is a kind of non-linear decision boundary like this, right? So a perceptron model only gives a linearly separable hyperplane. And as you introduce a hidden layer, you are constructing a non-linear decision boundary. You can see that here as an example, right? So for example, you have initially something like minus 30, 20, 20 you are giving to hidden layer, and here you have something like minus 10, 20, 20. Then finally you will get outcome something like this. So essentially what happens here, when both of 0 is 1, just a minute, give me a minute. One minute.
I think you're unmuted. We're not able to hear you. Are you there? Dr. Kuteti, are you there?
Sorry, actually there was some emergency. I had to attend that call. No problem. So what I am trying to say here is that, so you are introducing another layer here, right? That is your hidden layer. Now these are the weights that you are giving through it, right? So to this hidden layer, assume that these are the weights that you are giving, and essentially what happens is, because you are introducing one more layer, it is able to construct a non-linear decision boundary. So a basic neural network without any hidden layer may not be appropriate to solve complex problems, right? Now this can be extended. Am I audible?
Yes, sir.
Yeah.
Yes,
So
sir.
this can be extended to multi-class classification model, where you can increase the number of layers, but output layer is a kind of, in the case of output layer, you will use what we call a sigma, sorry, this is softmax function, right? So it is of the form minus z by sigma. So they will give probabilities, right? Suppose I have 4 classes: pedestrian, car, motorcycle, truck, right? Now assume that you are giving a truck, right? Now what you expect here is that these probabilities will be very low. will get 90. Out of these probabilities, this probability high that corresponds to car. You simply say that argmax of all these probabilities, where it will give you the class corresponding to highest probability. Okay, so that is multi-class classification. Whereas in the binary class classification, you will have only two classes, either class 1 or class 2, right? So especially these kind of complex multi-class classification problems or object detection, right? Segmentation, all such problems where you want to pinpoint that a particular region in the image. Let's say you have medical imaging data, right? So medical imaging data means, you know, it is like you have some specific spots in the X-rays, right? So that may not be very easy for recognition or identification in terms of diagnosis for a naked eye. So when you develop more robust feature engineering techniques and use these neural networks, then such medical imaging uh, diagnosis is very much uh, accurate, right? So that is possible because you are actually constructing numerical data from the features, right? So now what happens when you move in this direction, right? Let us say you have a color images, right? Color image comprises of three main layers: RGB, red, blue, green. This is red, this is blue, this is green. So these kind of images will have spatial distribution of data, right? Something like, when you are traveling in a helicopter, what you see in the downstairs, with a naked eye is your potential hills and valleys, right? So that is an example of spatially distributed data. So to extract features for such kind of spatially distributed data, typical neural networks that we discussed so far may not be very efficient. That's where we will be introducing the concept of convolutional neural network. Anyway, we'll see that in detail. So this is about deep neural networks. So any questions that you have on deep neural networks, or anything you want to share on this? Some of you might be working in this area to some extent. You can also share your experience, right? It is not one way communication. There should be some interaction, isn't it? Otherwise, it is also difficult for us to calibrate, and fine tune our uh, conversation, because if we are not able to fine tune our model, then the attention span will be poor,
Sir,
because you are spending time and you are attending this class, right?
sir,
Otherwise,
we are working on neural network and deep learning, sir. But this time we are learning all the details in very deeply, and we are very happy with this session. Please kindly continue as deep as possible. By that we can enrich our research also, sir.
no, that's okay. My point here is that we should be clear on when to use deep neural networks, when to use traditional models. Okay, so
Yes, sir.
to get into that level of detail, these concepts are helpful. Okay, thank you.
Yes,
No problem. So anything that you feel, you can always add, right?
sir.
It need not necessary that only I will be delivering this session, you can also contribute. That should not be a challenge.
Yes, sir.
Now, what we will do, we'll get into convolutional neural network. Convolutional neural network is extension of deep neural network with additional plugins called convolutional layer, pooling layer, and so on and so forth, right? As we move on, we will understand these concepts in detail. So, as I said earlier, convolutional neural networks are suitable for spatial density features, right? That means you have rich color images. Like any color image, if you see, you can slice it into three layers, right? First one is red region, next one is blue or RGB, red, green, blue, right? So because of which we'll get spatial distribution, and essentially each one is between uh, 0 to 255. Okay. These are it is. So what is convolution? I will explain. Convolution is a operation to extract spatial features, right? What we call filter, right? I will explain that in a short while from now. There is something called pooling. Pooling me is a kind of sampling from the pixels. Suppose these are pixels. Suppose you have like this. Now if you see here, right, these are pixel values, right? These are pixel values, right? So what you do is you want to apply some filter here by compressing these features. So that is called a convolution operation, right? This is your convolution operation. Suppose you have a 2 by 2 filter. So this is called kernel. How this kernel works, let me explain you. We are talking about convolution, right? So let me take some pixel values, 5, 3, some numbers I am taking. Don't worry about significance of these numbers. Suppose these are my pixels. This is my feature map. So these are my pixels of, let's say, one slice I am taking. Now I apply a convolution with a filter like this. 1, -1, 1, 1. Okay. So what happens is that I will place this on top of each of 2 by 2 grid, and I do the element wise multiplication. That means 5 into 1 plus 3 into -1 plus 6 into 1 plus 2 into 1. This gives you 5 minus 3 2, 2 plus 6 8, 8 plus 2 10. So this boiled down to single data point called 10 here. Now let me, now next what I will do, I will apply on this feature map. So first it will become 10. Now next will be 3 into 1
3
plus
into 1.
7 into minus 1,
7 into minus 1.
2 into 1
2
plus 1
into
into
1.
1.
Yes, sir.
This becomes 3 minus 7 is minus 4.
Excuse me.
Minus 4 plus 3 is minus 1. Right?
Yes, sir.
Because 3 minus 7 is minus 4. Minus 4 plus 2 minus 2 plus 1. Right? Now, next time what I will do, I will put this kernel here. Now that convolution operation will be 6 into 1
2 into minus 1.
plus 0 into 1 plus 12 into 1.
Yes, sir.
So this becomes 18. So this will become 18. Now next time I will put this grid here.
1, 2, 1,
Now
2.
this becomes 2 into 1 2 minus 1 that is 1, 12 plus 4 16.
Yes, sir.
Right? So initially I started with 3 by 3 feature map. I am applying 2 by 2 kernel. I am getting 2 by 2 final shape. I can write this as 3 minus 2 plus 1 cross 3 minus 2 plus 1. That means if my initial feature map is of size n cross n, right, and I am applying a kernel with some k cross k dimension. Now the feature map that I will get is n minus k plus 1 cross n minus k plus 1, right? That is the formula. Now the reason for that is that essentially the number of cells that you are compressing is essentially difference between n and k, and you are taking one out of that, that's why n minus k plus 1. Now this is called convolution operation. There is something called stride, right? So the concept
Right.
of stride means that you will be skipping certain steps in the sequence. That means suppose you apply, this is your kernel. Suppose, let's say, like this. Okay. Now assume that I'm using some stride of 2. That means first I will take 2 by 2 matrix here. Stride of 1 means I will do it from here. But stride of 2 means I will be doing from here. So in that case, this formula becomes n minus k by stride plus 1.
Plus 1.
Okay. So this is the typical calculation how it goes. So now let us go back to the slide. So the pooling is something that you want to construct a sample out of it. We'll do that little while from now. That means you just look at maximum value from that. So if you look at the key features of CNN, first thing is you will be dealing with local receptive fields. Local receptive field means Sorry. Local receptive field means that, so you will be looking at, instead of this, let me draw in this manner. Okay, suppose this is sheet. Local receptive means you are only focusing on that particular grid, right? Through this convolution. So you are basically capturing small local pattern, and you want to elevate that into larger structures. Second important characteristic is parameter sharing. That means there
Same
could be
because
overlap of these data points, right? That are your pixels when you are moving from one stride to another. There could be overlap of these pixels, right? So which actually help us to reduce the number of parameters. When you reduce the number of parameters, what does it mean? How you reduce the number of parameters? Basically, you are shrinking the size of the initial canvas, right? So essentially, you will be having fewer parameters and less overfitting. There is another property called translational invariance, right? So even when you move these, you know, within the objects, still you will be able to recognize this image because of the pooling that you are doing. Pooling means you pick up the maximum value from these grids, right? There is something called padding. I will explain that little later. So that's where in vision models, right? Image classification. What are the computer vision models? Image classification, object detection, segmentation. That means within the image, you want to highlight a particular point. You want to recognize a particular thing within that object. Okay, such kind of tasks put together is called computer vision tasks, right? So that's where your CNN models become very handy. Now let us compare and contrast deep neural network with convolutional neural network, right? As I said earlier also, any comparison that you want to do between two entities, you always consider different aspects. With respect to each of these aspects, you want to compare and contrast, right? So what are the aspects that you are considering? One is input handling, then feature learning, after that parameters and computational cost. Obviously when you have more number of nodes, more number of layers, essentially will have your computational cost will go high, right? Then performance on the vision task. Performance, how do you measure? That means in the in the classification setup, you have something like precision, recall, F1 score, and all that, right? But in the case of object detection, you will have area measures, area ratios that you calculate, right? Now, if you look at input handling, so CNN is suitable for spatial data, that is also called grid data, right? But whereas uh, fully connected neural network, that means typical artificial neural network, your data points are converted into a feature vector, right? So there is no information about spatial distribution of this data. Then it is more appropriate. In terms of feature learning, spatial features, it is more accommodative for spatial features because of convolution operation and as well as your straight that you are doing, because you just want to know most prominent features, right? Let us say if you take uh, movie um, actors, for example, right? If you take movie actors like junior NTR and senior NTR, right? So when you look at the spatial feature, essentially what happens is that the
Similarly.
uh, facial expressions, right? How they look like. So assume that you have a canvas grid, you have a pixel grid or feature map of junior, senior. Now what happens is that there are prominent regions where you have high pixel values in one map compared to other. But because you are using this convolution where you scan through this, right? What is this process called? Local receptive fields. Because of the local receptive fields, you are highlighting local receptive fields through convolution operation. You essentially be able to highlight these prominent features, right? But in the case of CNN, it is difficult to capture this kind of features because your data representation is just one dimensional and you don't have this kind of a feature map kind of a thing, right? Now, in the case of CNN, number of parameters will be few. And what are the parameters here? The parameters in the case of CNN is, of course, model weights and also kernel size. What kind of kernel I should choose? That also can be coming as your model parameters and values within that, right? These are all will be learned by your network model. And CNN compared to CNN, in the case of neural network, you'll have obviously more number of parameters, but you try to reduce that complexity to some extent by using various techniques called batch normalization and dropouts, right? When you introduce dropouts, what will happen? You will switch off some of these nodes in the network so that in effect, not all nodes are participating in your model
Computations.
construction, right? So then then when it comes to computational cost, it is more efficient, it is expensive. We cannot actually say in the computational cost saying that CNN is better than fully connected, because that is subject to nature of computations that you are doing, right? For example, I will tell you, suppose you want to compare flight journey with train journey, right? You cannot say cost flight is more costlier than train. That is not a meaningful comparison. Why? Because obviously we know, right? Obviously there is a cost imperative associated with that. But but critical thing is where a particular
ధర్మం
thing
కోసం
is
కావచ్చు,
applicable.
కుటుంబం కోసం
That's what
కావచ్చు,
we need to see.
మరి ఏ ఇతరత్ర కారణాలైనా
So
జరగవచ్చు. ఈయన వలన కొన్ని కోట్ల మంది చనిపోయారు, 100 కోట్ల మంది చనిపోయారు దాదాపుగా. అయితే
can you be on mute, please? If you are not interested, please drop off. Okay, there is no compulsion that you need to attend this, at least from our end.
Sorry, sir. Sorry,
It
sir.
is absolutely fine, whoever it is. Now, so when you look at translational invariance, right, that is achieved through convolutional pruning. What is translational invariance, right? One example for translational invariance is if you take a function, if you take the first derivative of the function, right, it is translational invariance if it is a constant. 1 minute. Give me a minute. Suppose when you say x goes to x plus constant, then dx prime is also dx. This is your translational invariance because this is not going to change anything with respect to your feature maps, right? Now let us look at this very classic text from which I have taken. I have given the reference also here, source here. So assume that we want to classify images like cat and dog. So you give it this to the model called fully connected feed forward network, where you use convolution pooling. You always use convolution and pooling in in alternative sequence, because convolution is operation that you do to 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 capture the compress to compress these features, right? And maximum pooling, what it does, it will capture most prominent feature. For example, you have image of a cat and cheetah, right? Even though both of them look like similar, but because of this convolution and maximum pooling, you see that the facial data distribution, let's say eyes for example, there you see significant difference, but with the naked eye you might see that cat is smaller version of cheetah, right? But you will see that kind of a clear cut demarcation because of this convolution and pooling, which you are repeatedly applying here. Now, what are the properties that you see here? When you see patterns, right? So these patterns are smaller than image and they are recurring patterns, right? Appear in different regions. And because of the pooling, you are doing subsampling the pixels, and it will retain the most prominent features, but at the same time it will reduce your overall dimension and complexity. Similarly, if you look at a kind of segmentation task, and there are different birds, the beak slightly different, right? You want to classify based on that. So this is something like a big detector. When you want to do such kind of uh, loaded features, you can detect through the filters, the concept of filter or kernel that we are talking about, right? This is called localization. You remember we discussed about localization or local receptive field. So you can see the graphical representation of this local receptive field. Now, this is again an example of how do you do convolution. There is another important thing called padding. The reason why do padding here is that you want to take into account the corner regions, right? So, for example, let me just explain this. Suppose if you see here, now these values 2, 3, 4 I have, right? Now, when I do this convolution, I do convolution like this, but I am not able to consider this multiple times, whereas the central region is having a lot of overlaps with different strides. So in order to depict these boundary features, what I will do, I pad on the either side, right? Let me just let me just 3 by 3 I will take. Now, when I, let's say I pad on either side like this. Suppose you have like this. So what happens? You are increasing the dimension. like this. Now what happens compared to earlier thing? Now you are able to do straight from here. This one, this one, right? Earlier this appeared only once. Now it will appear multiple times because it will come like this, right? So because of the padding, what will happen? You are able to consider these boundary features and revisit them to extract more prominent aspects on the boundaries, right, or edges in the image. So this is about convolution and as I said, computer vision tasks. There are three tasks that we talked about, like classification, object detection, and segmentation. So next comes prompt engineering. So of course, prompt engineering is a skill because now if you look at the industry, this has become very prominent role, especially people who are from testing and QA background, right? They want to enter into a discipline. The best way to get into that is through become a prompt engineer. After that, you can become generative AI developer. After that, you can become agentic AI developer, or you can choose in between ML engineer, data engineer, and different tracks, right? So all these roles are depending upon the kind of workloads that we deal with in real life day to day basis, right? Like the way we have earlier traditional applications, the kind of workloads that we have is requirement analysis, and then use case modeling, high level design, low level design. Parallelly you will have traceability matrix. For each use case you write the scenarios and write the test cases. Unless each of them pass, you will not, scenario is not complete because you have core life cycle. Similarly, we have a life cycle and workloads here. Depending upon that, we have a lot of roles that are evolving, right? So basically, prompt engineering is an art of designing prompts, that means simple English statements for large language model, something like Chat GPT. What is GPT? Generative pre-trained transformer model, right? So So there are certain things we should always consider in while generating the prompts. One is clarity and specificity. The other one is context you want to attach through giving some examples to the model. Giving these examples is called prompt design strategy. There are multiple strategies we have, like zero shot, one shot, and chain of thoughts, etc. We will discuss them in detail. Now, when you talk about each of these aspects, clarity, uh, instead of saying explain photosynthesis, you say that explain photosynthesis in simple terms for a particular persona. So, clarity and simplicity is brought into this interaction between the prompt engineer and LLM by bringing in persona. That means a role. Suppose I want to explain in a singular value decomposition to a 10-year student, how do I explain? That means you are bringing a persona. Suppose I want to explain code refactoring for a developer of 2 years experience. That means you are bringing in persona. That actually brings in clearly what you is expected, and you are specifying that expectations there. Then providing the context. You are giving some examples, right? So you want to give some context associated with that. Let's say For example, I want to design uh, some 3 marks problems on something like uh, optimization, right? We have this problem called simplex method. We know that it is not possible to design a 3 4 marks problem in optimization simplex method. Simplex is more detailed one, right? So you should not get into that kind of a thing, right? See, based our ability of giving right prompts will also indirectly help our universe, because if you give very bad prompts, then it will be training on multiple large number of parameters. Because the model is getting trained on large number of parameters, there is something called a temperature, right, which is essentially connected with execution time and heating effect and all that, right? So that's why we should be responsible in design of these prompts. So another aspect is inspect and adapt. That means iteratively you try to improve and paraphrase these prompts. And there are certain things, as I said, few short techniques, chain of thoughts, right? Chain of thought is a kind of a setup that you create to the model. You facilitate the model to think in a very, very logical, chronological order. That is called step-by-step thing. Why do we care about prompt engineering? Because it is important that our prompts are well defined, because you will get less errors, or what we call the effect of hallucination will be less. I will explain about hallucination little bit later. So these are the techniques, right? One is zero shot prompting, few shot prompting, and chain of thoughts. This is the typical differences between them. One shot prompting is essentially means you are giving one example as a prompt. You can look at this example, right? So you see, translate the following sentence to French, right? You say one example, I love music means this is something. Now you translate it. You are giving one example already. Few shot prompting means you are giving more than one example. Chain of thoughts means you are giving step by step thinking. If a train travels 60 kilometers in 1 hour, how long it will take to travel 180 kilometers? Then you try to give some kind of step by step thinking to it, right? Each of these strategies has different purpose. For example, when you are applying a chain of thought approach, this is more suitable for mathematics and logic related problem solving. Few shot prompting is if you want the model to learn some hidden patterns, for example, right? So typical use cases of one shot prompting is text classification, summarization, whereas few shot is complex classification, and chain of thought, math problems and logic puzzles, reasoning type of questions, right? Of course, they do have their own uh, limitations, right? So little bit of expertise in Python might be useful. So you can think of some example here. Notebook
Welcome to
LM.
Notebook LM. This is where you can start exploring the power of generative
You
AI.
can hear this, right?
The first thing you need to do is start a new notebook. Select the Create button here to get started.
So this is an
Once
example.
you do that,
How
you'll
do
be
we do
prompted
that?
to
I will skip this considering the uh, time. Now let us look at the concept of hallucination. That means a model try to give some predetermined notion or incorrect or fabricated information, right? That means, but factually that kind of information might be wrong, and this can be because of erroneous inputs. You are applying chain of thought strategy, but every step that you are giving misguided information to the model. So there are some of the practices you can use to reduce this hallucination. One, you give the precise and most context relevant prompts, and you try to construct the prompts to be step by step manner in a chronological order, and chronological and logical order also, right? It should be logically relevant. So this is how it is. Now these are the couple of examples that we have. Explain how Apache Kafka used in real-time streaming, considering a beginner in data science. That means computer science. That means persona. Please always try to give persona when you are thinking of a prompt, right? So there are some sample questions we can expect in the exam. Like for example, you can answer these things, right? You can go through the questions and tell me which option is correct in this case. What is the persona pattern? Because it makes the model to assume a specific role. Now, which of the following is example of persona prompt? Can you guess? Second one. So why are the persona prompts are used? Because they help in model for tone, expertise, and a perspective. You can't guarantee a elimination of hallucination by just using persona, right? Now look at this example. Suppose a teacher designing the prompts for educational chatbot, right? Which technique best apply? Patient tutor, right? So you can think of setting a persona and role play. Now, of course, these kind of promptings will lead to some kind of bias in systems. So one example is human bias, which is embedded in the training data, right? And again, fairness is another aspect. It aims at providing equitable treatment across different people, and so on and so forth, right? So these are the some of the examples I have. So that's all I have. Thank you. Any questions you can ask me now. Hope this is informative, because there are so many things we can cover, but we need to strike a right balance, right? We can't just hurry and speed up the things unless we have logical construction of these concepts. It won't make sense,
Absolutely.
right? Yeah. Thanks,
Absolutely.
madam.
Absolutely.
Thanks for the
Thank you. Thank you,
understanding
sir.
and
Thank you.
giving me support. Thank you.
No, absolutely. I'm grateful to you because in spite of this family thing, you made time for this session. I really appreciate that, and thank you to all the faculty members who attended. Uh, you are attending and you are giving your time, so please do make the best use of this time. It's just my request again and again. That's all. Because there is an assessment that you have to clear and you have to score 70% marks for that Atal certificate. So thank you so much, sir, and all the faculty members. I'll see you again tomorrow at 6 o'clock. Thank you.
Thank you. Bye.